Okay, so let's try to draw the Lewis structure for something with a charge, such as nitrate, which carries a negative charge. Okay, so we're going to use the same procedure that we discussed in the last video about drawing a Lewis structure. And so the first thing we do is count the valence electrons. And so the valence electrons for a nitrogen atom is 5, right? And then we have 6 valence electrons for each oxygen atom. So plus 2 times 6. Plus we add another electron here because we have a negative charge in the molecule, all right? And so that gives us all told 18 total electrons, all right? So now we're going to start to distribute this. First, we're going to identify a central atom. So nitrogen seems like a logical choice here. And we sandwich that between 2 oxygen atoms, all right? We start by adding 2 electrons between the central atom and each pendant atom, okay? But what you'll see here is that we have no other pendant atoms to distribute to, and we only have 4 electrons around nitrogen. So we have to add some more electrons to nitrogen just to satisfy the octet rule. Okay, and if we do that, right, now we satisfy the octet rule for nitrogen. We have 8 electrons, which means we have 10 more. We have 10 more electrons to distribute. Okay, and so we don't typically, except for a few exceptions, distribute, for instance, single electrons to an atom in a Lewis structure. So we can think about unevenly distributing this. So maybe we put 6 on this oxygen atom over here and 4 over here for 10 total electrons. And now if we count them, 2, 4, 6, 8, 10, 12, 14, 16, 18, we have distributed all 18 electrons. However, we have a major issue here, right, that one of the oxygen atoms, right, does not satisfy the octet rule. So there's only 6 electrons around this oxygen atom. So this is not a valid Lewis structure. So we can't use this as our interpretation using the Lewis structure. So what we instead do is we can think about putting another set of electrons from the nitrogen maybe down to share with this oxygen atom. And when we do that, right, we have 2 pairs of electrons between the central atom nitrogen and one of the oxygen atoms. In other words, we think of that as a double bond, okay? And so now, right, we can look at the octet rule for each of these, right? The oxygen atom has 1, 2, 3, 4, 5, 6, 7, 8. Okay, the nitrogen atom has 1, 2, 3, 4, 5, 6, 7, 8. And then this other oxygen atom has 1, 2, 3, 4, 5, 6, 7, 8. Great. We have now satisfied the octet rule for each of our atoms here, okay? And so we will think of this as having a double bond between the nitrogen and one oxygen, and then a single bond between the nitrogen and the other oxygen. So now we have to look for formal charge. And so the way we will calculate formal charge is, now that we have the Lewis structure, we're going to look at we're going to assign electrons to each atom, okay, based on a process we're going to discuss here. So lone pairs, right, belong to the atom that they atom that they are attached to, okay? So for instance, this lone pair of nitrogen belongs to this nitrogen. We'll assign it to that, okay? But, okay, electrons that are between 2 atoms, okay, are going to be shared equally. So there are 4 electrons between the nitrogen and the oxygen over here. So we're going to assign 2 electrons to the center nitrogen, and 2 electrons will be assigned to the other oxygen. Over here, between nitrogen and the other oxygen, right, there are 2 electrons, so we're going to assign only 1 to the nitrogen, and the other electrons get assigned to the oxygen, and then this lone pair belongs completely to the nitrogen, okay? All right, similarly, right, the oxygen atom, the 2 lone pairs, the electrons in the 2 lone pairs are assigned to this oxygen, and then these 2 electrons over here are assigned to this oxygen atom, and then over here, these lone pairs are assigned to this oxygen atom over here, and then this 1 electron here. stays there, is assigned to this auction atom.